Hi and welcome to yet another Imp engine video. I'm just building this engine for a customer, and I thought it's a first time I've done this particular spec of engine. It's called the Stealth engine. It's a 1200cc engine, but all inside the standard height block. So externally, the engine will look just like an absolutely standard Imp engine, obviously barring the carburation and exhaust and things. So this is a Talbot Sunbeam 930 block, bored to 74mm with the top outliners that I do. So that's all pretty straightforward. This is the Farndon crankshaft, which is 69.5mm of stroke. That's all well proven, been used in the race cars for years. And then the bit that's changed is, obviously we've got some steel rods here. These are standard length, 105mm length standard rods. The tricky bit is in the piston. So because obviously we've got 10mm more stroke just about on the crankshaft, to stop the piston from popping out top of the block, we've had to get the piston made with 5mm shorter compression height. Now the compression height, just for those of you that don't know, we'll just get something to point with. Preparation is a bit poor. Is the centre line of the crank pin, of the little end pin, to the top deck of the piston. So that's your compression height. So normally on an Imp, this would be 5mm taller, but on this piston it's 5mm shorter. So obviously 5mm at the bottom, 5mm at the top. That's where our 10mm for the stroke comes from. So this all goes round. I've dry built the engine. I know it all goes round. I've had to do a bit of playing around with things to make it all fit. I've got a nice big valve head for it, all ready to go with some good sized ports on it and some what I call like my wasted guide, just to help the airflow as best as possible. And then it's got a nice Carter cam carrier with one of the modern cam profiles that get done, like a very high lift but very short duration, because what this engine is all about, and what we'll see in the next few minutes on the dyno, when obviously I've built the engine and we put it on dyno, is we'll see the torque. It's all about torque, this engine, because it's going in a road car. It's not all about top end horsepower. I just would hope to see like the 90 foot-pound of torque. That would be awesome, and if we had a nice spread of it, that'd be even better. Now, I'm not going to go crazy on this subject because it's quite a sort of complex subject, but the rod to stroke ratio, which is the ratio of the length of the rod from the center of the little end to the center of the big end, obviously offset against the length of the stroke. That's what decides where the engine is going to do its torque, amongst many other things like camshaft, etc. So as standard, an Imp has, say, a rod length of 105mm and it has 60mm of stroke. So that ends up being a rod to stroke ratio of 1.7. So that's not a bad figure, 1.7 rod to stroke ratio. It's thereabouts. It's all right. Ideally, for running higher RPM, we could do with a bit of a longer rod. So that's why I did the long rod engine, which looks like that one there with the spacer on top. So that rod was I think 120mm long, and that gave a rod to stroke ratio with the 998 crank of like 2 to 1. Now, because we've got the long stroke crank here with the standard length rod, the rod to stroke ratio now is down at 1.5 to 1, which doesn't lend itself to high RPM. And the reason for that is we'll see big angles because it's such a short rod. As the engine goes round, we'll see a lot of angle on the rod. And there's loads of theories about side load on the piston, etc. But for me, the one thing that changes is the rod length denotes how the piston accelerates and decelerates away from top dead center. So the shorter the rod, the faster it passes over top dead center, and the longer the rod, the slower it decelerates, and more importantly, the slower it accelerates away from top dead. And what that does is it shifts the torque band up the RPM range, because it gives the piston more time to absorb the energy from the flame front. Because obviously, if you ever look at any torque graph, you always see the torque fall off as the engine gets faster. And that's purely because even though the power may continue to increase, the torque will fall off because the piston's going so fast, it just can't absorb the energy from the bang. So that's what the rod to stroke ratio job's all about. If you Google it, there's loads of information you can look, and I'm sure it'll be explained a lot better, but that's just a basic. So I'm going to build this together now, and next video will be hopefully on the dyno, ready to run, and we'll see if it's got the torque that I'd like it to have. Okay, right, back with the short motor now. Just built this up, so I just thought I'd do a little video, a little bit of an interim video, just on the assembly. You can see it's got quite a bit of stroke now, going from 60mm to 69.5, and the bore size on an 875 is like 68mm, and this is 74, so we've really gone up quite a bit. Obviously this engine is going to run with a fuel injection system, so it's on a crank trigger at the front, like a 36-1 trigger. Just put the camera here a second and spin the engine over. Bit of cardboard here to lay it on. No, that's not going to work, is it? Go that way. Beauty of an Imp engine is very light, so you can actually handle it quite easily around the shop. Okay, so let me see inside there now. So you see the steel crank and the steel rods, and also the forged pistons. One thing I was really happy with these rods and pistons was, I don't like it when you've got a little end that rattles around inside the piston with loads of space. So if you look at this one, try and zoom in a bit, you'll see I've had the rod designed with a wider little end, so that it shrouds the pin as much as possible, so the pin doesn't end up bending, because that is one of the issues we do see with engines that do a lot of RPM. The stresses of making that piston change direction are so big that it actually bends the pin and ends up making the bronze bush start to fail. But yeah, so there we are, a little bit of a video. Next one we'll have will be on the dyno, with it all running. But, yeah, I'm quite pleased with that. I think it's going to be nice. This, you can see it gets rather close inside. I have got a slightly longer liner in this engine, just because I wanted to shroud the piston as much as I can at bottom dead centre, to try and help keep it all nice and quiet and give the piston a bit of stability. Okay. Right, it's my favourite part of every build where we dyno the engine. So the 1200 Stealth is on dyno, ready to go. I've already run it in a fair bit, so we know what it's going to do. It's doing exactly what I wanted it to do, which is a good thing. This engine, obviously, it's all about the mid-range torque. I'm not fussed about where it does up at 8,000 RPM. I wasn't chasing horsepower. I wanted a good flat torque curve from low down, so that it'd be a nice drive, because it is going in a road car. Now, as you can see, we're on an old set of carbs at the moment with very small chokes, and we've only got 30mm chokes, and I'd normally run this on something like 34s or 36s, but I'm just proof testing the engine. The engine is now going to go to get mapped at another engineering workshop, and then we'll get some accurate figures and with the proper air setup on it, etc. And the electronic ignition. I'm going to give the guy a bit of an idea what advance. Talking about the advance, really interesting. Didn't want anything like as much advance as I thought. It's only 11.7 to 1 compression, this engine, which is quite low for an Imp. But another learn the way, because it's on the short rod, and the way the piston accelerates and decelerates away from top dead centre quite fast, I think that's affected the advance. I'm lucky to get like 25 degrees in it. It doesn't want any more, which is, you know, it's obviously burning quite fast. So all a big learn. There's a few other bits on the engine which I'll just swap the camera around now, what to talk about before I run it. That's it. Hope you enjoyed the video. Right, one of the things I want to talk about on this engine was the oil cooler setup. So I used a sandwich lemon over type exchange unit, and I normally used to run these on the full system. So the cold water from the radiator would go in at full bore there, come out here, and then back in the engine. But it was just all a bit untidy, you know, with pipes everywhere. I wanted something that the engine could leave here with the oil cooler on, and all the customer's got to do is plonk it in the car. They haven't got to worry about anything. So what I've done is, if you look inside there, that normally is a water drain from the block. Now I was thinking the water's only coming cold here at the front of the block, so it should still be relatively cool here. So I took the water out there. Now if you've got a thermostat in which this has a 74-degree stat, obviously we'll have a resistance in the block for the water trying to go that way. So it forces the water through the cooler and then out the cooler, and then that goes up along here. Lovely Will Parry special there, exhaust manifold, lovely exhaust. And then it enters back into the free side of the thermostat. So obviously the hot water from the cooler now joins the rest of the hot water off to be cooled. So as yet, I've run the engine up to sort of 80 degrees. I've run it under load at sort of 70, 75. And it's not yet turned the first colour on the cooler, which is 71 degrees. So I'm quite happy for the oil to run up to 100 degrees on the modern synthetic oil. But we're nowhere near there, so the cooler's working great, so I'm really pleased about that. Other things I was going to talk about was the sump and the new baffle plate, which I've had done rather than being done as a water jet cut plate. I've had them done on a CNC, which is a little bit more expensive, but if it makes a nicer job, you know, it's worth having, isn't it? And then that was a cast alley sump that the customer said he'd like, and I pulled a face because it weighed more than the standard one. But customer's always right, so yeah, he loves it. He loves that sump and his posh cam cover as well. An original Grief from Engineering one. So I'm gonna go in there now and run this, and we'll see what it does. Right, we're running, and like I said before, we've got moderate amount of advancing. Probably a little bit too much fuel. It is rich, it does go very rich if it drops below 2,500 RPM, but that's just carburetors. Oh, there we go. It's got all groggy on me. But I'm just going to leave it that way because I want to keep it all safe. And then when it goes off to be mapped with the fuel injection on, maybe we'll try and get a video of them guys and try and add that to the YouTube channel. But for now, what we'll do is we'll have a look, see if we can get, I'll load it up, see if we can get a nice low down figure. I can feel it's mega torquey, it just wants to work. At 4,500 there, we're seeing nearly 87 foot-pound, 5,000, yeah, about 87 foot-pound at 5. Mark that down. So I'll try and get it a bit lower than that, but I think there's more to come. I think the peak torque is going to be about 4.5 on this. Right, we'll have to scrap my previous statement about peak torque being down at 5. We've got it loaded up at 6 now, and it's pulling nearly 93 at 6. So it's still climbing, which would be good for horsepower. Quite surprised about that, quite surprised. Always learning. Right, so we'll say that was... okay, we'll just go back to the 5,000 figure. Okay, well we know what it's doing down below now, so we're going to back the dyno off, and we're going to start it, let's say, about 5, and we're going to run it through to about, we won't be too cruel to it because it is all brand new, but it needs to see 8,000 before it leaves here. It's holding it there at 6.5, we're still on 90 foot-pound, still 80, well it's dropping off now, and it's still yeah, it didn't fall off as bad as I thought. It's going to be quite powerful, this, which wasn't the original design intention. It was all about torque, but anyway, it is what it is. I'll convert some figures for the customer. I hope you enjoyed the video, and we're back on soon with some more.